Hello students, in today's video I will take up the chapter solution and will give the formula list to solve the problems. Now to calculate mass percentage, which is called as the weight by weight W by W, mass of the given component divided by mass of the solution into 100. Now here in both the cases I can take grams and grams, correct? Now volume percentage is a weight by weight, volume of the given component divided by volume of solution, both in terms of ml wise and ml wise into 100. Okay. Similarly, we have got the mass by volume percentage, that is a W by V, where one of the component is in terms of grams, mass of the component divided by total mass of the volume of solution in terms of ml wise, in terms of grams into 100. Okay. To calculate molarity, molarity capital letter M is equal to number of moles of the solute divided by volume of solution in terms of liters. Or you can also write number of moles are equal to given weight of the solute divided by molar mass of the solute divided by volume of solution in terms of ml. That ml can be converted into liters by dividing by 100, that becomes into 1000 here. Okay. Similarly, molality is equal to weight of the solute divided by molar mass of the solute into 100 divided by weight of the solvent in terms of grams. How to calculate mole fraction? We can calculate mole fraction of the solute and mole fraction solvent. Remember, the subscript 1 is always for the solvent and subscript 2 for the solute. So, mole fraction of the solute is equal to N2 divided by N1 plus N2. Mole fraction solvent is equal to N1 divided by N1 plus N2. Remember always the sum of the mole fraction is always equal to 1. Here x1 plus x2 is equal to 1. Now whenever we are diluting the solution from solution 1 to solution 2, use the formula M1 V1 is equal to M2 V2. M1 V1 before dilution and M2 V2 after dilution. Here we can calculate the molarity after diluting the solution. Okay. See the relation between molarity and density of the solution. Molality small letter m is equal to molarity capital letter M divided by 1000 into density. This density in terms of gram per ml or gram per cm cube minus molarity into molar mass of the solute. See, remember here the subscript 2 is there. This is for the solute, molar mass solute into 1000 it is. Okay. Now how to find out molarity using density of the solution? We have got molarity is equal to percentage into density into 10 divided by the molar mass of the solute divided by molar mass solute. So we can calculate here molarity. How to get ideal solution? To get ideal solution, you have to mix two liquids and assume that both the liquids are volatile. Both the liquids are volatile. Then the total pressure of the solution, vapor, the total vapor pressure of the solution for the ideal solution using Dalton's law. Using Dalton's law, total pressure is equal to partial pressure of the first one plus partial pressure of the second liquid, vapor pressure of the second liquid, or PA is equal to P naught A into XA, where X is the mole fraction that component in the solution. P naught A stand for the vapor pressure in the pure state. So we can make use of PA naught into XA plus PB naught into XB. Okay. How to calculate relative lowering of vapor pressure? This is for the solid solute dissolved in the liquid. So solid solute in the liquid. Okay. After adding the solute, vapor pressure decreases. So it is the P naught minus PS divided by P naught. Okay. Remember P naught stand for the vapor pressure pure solvent, and PS stand for this is the vapor pressure of the solution containing non-volatile solute, which is also equal to x2 mole fraction of the solute it is. And for dilute solution, mole fraction is equal to N2 divided by N1 and N2 is equal to W2 given mass divided by the molar mass. N1 is equal to given mass divided by molar mass, correct? So that's what is written here, W2 divided by M2 into M1 divided by W1 after rearranging it. Clear? How to calculate elevation the boiling point? Elevation boiling point means increase in the boiling temperature with respect to the solvent here. Okay. Now delta T B is equal to Kb into molality. M stand for the molality, Kb stand is a constant called the molar elevation constant or Ebilopis constant. For water is fixed value, depends on the nature of the solvent for 0.52 Kelvin. Okay. Molality inverse, right? Now suppose they give in terms of weight of the solute and molar mass. So delta T B is equal to Kb into 1000 into W2 divided by W1 into molar mass, right? Similarly, we have got depression the freezing point. What difference freezing point? Formula delta TF is equal to Km into molality. Kf molar depression constant or cryoscopic constant, whereas the Kf is equal to 1.86. Okay. And how to calculate a delta TF? Delta TF is equal to Kf into 1000 W2 divided by W1 into molality. So into the molar mass of the solid is what here, right? How to calculate osmotic pressure? Osmotic pressure symbol is pi. Pi is equal to CRT. C stand for the concentration in terms of molarity. How do you calculate molarity? Molarity is the number of moles divided by volume in terms of liters. Or how do you calculate number of moles given weight of the solute divided by molar mass whole divided by V. So on rearranging you will get pi is equal to W2RT into divided by M2 into V. So remember R value is in terms of 0.0281 in terms of atmosphere liter per Kelvin per mole, volume in terms of liters, osmotic pressure in terms of atmosphere there. If there is isotonic solution, what do you mean isotonic solution? Isotonic solution means those solution whose concentration same. When the concentration is same, then the osmotic pressure pi 1 is equal to pi 2 for two different solutions. Okay, having same concentration because pi is directly proportional to C. When the concentration is same, osmotic pressure also same. Thank you, students. Have a nice day.